Hi, this is Mrs. LaBarbara. This is Physics Chapter 10, Waves Intro, Video 1. Today's topic is vibrational motion. The objectives are know what a vibrational motion is, know vocabularies to describe a periodic vibrational motion, cycle, period, frequency, and amplitude. Understand all periodic vibrational motions needs a restoring force. Understand the sinusoidal nature of all periodic motion. Understand the relationship between period and frequency. Be able to determine the period and frequency and amplitude of a wave. Describing a vibrational motion. Here are the two animations showing vibrational motion. So a bob head is a vibrational motion. Also, when you hit this is a symbol that's also vibrational motion. So vibrational motion is a back and forth motion. All vibrational motions has a resting position. So for bob head, the resting position is right when the bob head is in the middle. For the symbol, the vibrational motion is when it is at rest. To make the object vibrate, a force must be applied. You have to push the head to start it. You have to hit the symbol to make it vibrate. As the object reaches its maximum displacement, it stops momentarily before it moves back. As bob head comes to the side, it goes back. Why it goes back? Because there is a restoring force pulling it back. So the object, however, when it comes back in the middle, it doesn't stop. It does not stop because of inertia. An object in motion stays in motion. As you can see, this one, it will comes back in the middle, then it keeps going, eventually it stops. It stops because of damping. So damping is a tendency of a vibrating object to lose its energy over time. A sustained input of energy would be required to keep the back and forth motion going. The easiest vibrational motion is periodic motion, such as an object on a spring or a pendulum. If the to describe periodic motion, we use vocabularies, cycle, period, frequency, and amplitude. If a vibrating object is moving over the same path over the course of time, that motion is called periodic. So each complete path is called a cycle. Complete path means, let's talk about this pendulum. From here, coming back, that's one cycle. From here, coming back, that's another cycle. Or you can go for the middle. From the middle, it's going to the right, left. That's 1, 2, 3 cycles. From here again, this is a pendulum going up and down and coming back. That's one cycle. You can go to the lowest point. When it comes back to the lowest point, that's one cycle. The time it takes to complete one back and forth cycle is called a period. The amount of vibration in 1 second is called a frequency. So you use a timer, you time 1 second, say how many vibrations this spring had. That's called a frequency. Frequency is how often the object vibrates. The other vocabulary is amplitude. Amplitude is a displacement, the maximum displacement from the equilibrium position. For a pendulum, it would be that angle. The maximum angle can go either to the left or to the right. For a spring, from the equilibrium when it's neither stretched or compressed to the maximum stretched or to the maximum compressed position. That's called amplitude. Sinusoidal nature of a vibration. So if you graph the displacement of this mass on the spring versus time, you will get a shape of a sine wave. So all the waves, periodic waves looks like this, a sine wave. So one cycle is from this, one cycle is from the lowest point to comes back to the lowest point. That's one cycle. So here is multiple cycles. So the cycle would be from A to E or E to I to M. So there's many cycles here. That's 1, 2, 3, 4, 5, 6, a little bit over 6 cycles in this time period. Damping occurs. Damping means the spring is eventually going to stop. So as you see, it started from 0.6, it started going to 1, and when you're getting to like 14 seconds, it doesn't reach 1 anymore. That's called a damping. And even with the damping, the time to complete one cycle is about the same. So A to E, that's the first cycle, is about 2.3 seconds. Let's take a look at the last cycle. Last cycle from like a little bit over 11 to a little bit over 13. So it's also about the same. Okay, so the cycle is about the same, even with damping. Now let's take a look from this diagram. Let's see if we can find a cycle period and frequency and amplitude on this wave. So cycle is just one set of regular pattern from A to E. That's one cycle we talked about. But B to F is another cycle because it's corresponding the same point. You're going from the highest point to the next highest point. So another one is C to G or G to K. That's a cycle because you're coming to the same position. And H to L is another cycle, or D to H is another cycle. Period is a time it takes to execute one complete cycle of motion. So T is in second. That's a standard unit. In this case, from A to E, I estimated about 2.3 seconds. Frequency is the number of cycles or vibration in 1 second, number of vibrations in 1 second. So let's take a look. 1 second is over here. So how many waves is that? It's less than half waves. So I estimated to be about 0.4 waves. And the unit for frequency is hertz. Hertz is 1/second. So it's 0.4 hertz. Basically is number of waves per second. The other vocabulary is amplitude. Amplitude is from the equilibrium position, in this case is 0.6, to maximum or minimum displacement. So in this case, maximum is 1. So the amplitude is 0.4 meters. So either going down, you can say the amplitude is -0.4, but in this case, amplitude is just number. Negative means downward. So what does amplitude represent? Amplitude represents energy. The amplitude is defined as maximum displacement of an object from its resting position. The resting position is the position assumed when the object is not vibrating, is the resting position in the beginning, right? Over the course of time, the amplitude tends to become less and less. So here is a diagram to showing amplitude is getting less and less. This is called the damping. So damping will decrease the amplitude and therefore decrease the energy. That's what amplitude represents. You probably have been to the ocean. So sometimes the wave is huge. When the wave is huge, the amplitude is huge because when the water is not moving, it's at rest. When you have big waves, that's a bigger amplitude. So that means that wave has a lot of energy. That's why you have to stay away from that waves, right? So again, the amplitude of motion is a reflection of quantity of energy possessed by the vibrating object. So again, amplitude is from the equilibrium to the maximum or equilibrium to the minimum. So both are amplitude. Has to be from zero displacement. Let's take a look at this example, amplitude, period, and frequency. So in this example, the amplitude is from 0 to the highest position is 0.01 or to the lowest position, also 0.01 meters. The period is time for one wave. Time for one wave is 1 cycle. So from here to here, that's first cycle, which is 0.05 seconds because this horizontal is in seconds. Frequency is the number of cycles per unit of time. So we kind of have to calculate. So let's see, this one shows there's 2 cycles. 2 cycles is in 0.1 seconds. So in 1 second, you would have 20 cycles. So the frequency would be 20 hertz. Now let's see the relationship between period and frequency. They are actually inversely related. So here are two pendulums. They have different period and therefore different frequency. The first one, as you can see, the period is longer. That means this pendulum on the left is vibrating less frequently. The second one, the period is shorter. It's going kind of like faster, right? So it's have a shorter period, has a higher frequency. So period is time one cycle, time of one cycle, or the total time divided by number of cycles. Now frequency is the number of cycles divided by total time. And they are inversely related. T equals 1 over F and F equals 1 over T. Let's take a look at this example. So a pendulum is observed to complete 23 cycles in 58 seconds. What is the period and frequency of this pendulum? So let's write down what we know. Cycles, 23 cycles. The total time is 58 seconds. Period is total time divided by number of cycles, which is 58 seconds divided by 23. You'll have 2.52 seconds. So that means one cycle, it takes 2.52 seconds. Frequency is the opposite of period. So it's the number of cycles divided by total time, which is 23 divided by 58 seconds. You have 0.4 hertz. Or you can see 0.4 equals to 1 divided by 2.52. Let's take a look at another one. A mass is tied to a spring and begins vibrating periodically. The distance between highest and lowest position is 38 centimeters. What is the amplitude? If you draw a picture, so here is displacement, here's the highest position, here's the lowest position. So from the highest to lowest is 38 centimeters. The amplitude is from the middle to the highest or from the middle to the lowest. So the amplitude has to be 19. By the way, the period is time for one cycle. So one cycle is corresponding point on the wave. It doesn't have to be from 0 to 0 or highest to highest or lowest to lowest. It just have to be from the corresponding point. So that's a period from here to here. That's one cycle. Another example, a physics student takes her pulse and determines that her heart beat periodically 80 times in 60 seconds. What is the frequency of her heartbeat? So here is again, cycle is 80, time is 60, frequency is cycle over time. So it is about 1.33 hertz. So basically her heartbeat 1.33 times in 1 second. Another example, what is the period of a wave if 4 complete waves pass a fixed point in 10 seconds? So again, the cycle is 4, time is 10. So what is period? Period is total time divided by cycle, which is 10 divided by 4, give you 2.5 seconds. That's it for today. Thanks for watching. See you next time.